Welcome to Anime Effects in Houdini and Nuke. I'm Rez, I'll be your instructor for this workshop, and I've been working in 3D for more than 15 years now, and over time I've experimented with a ton of different workflows, tools, and software, and a lot of this experimentation was figuring out how to create stylized effects, especially anime style effects. And honestly, that's pretty much why this course exists. I wanted to take all the techniques, experiments, all the little tricks I've gathered over the last 15 years and really push them as far as I can. The goal is to get as close as possible to that hand-drawn anime feel, but using Houdini and Nuke. Now, before we jump into the projects, we'll take a quick look on how the course is structured, just so you know ahead of time what's coming and in what order. And I also want to go over a few things and questions you might have. So hopefully when we start with the actual projects, you'll have a clearer idea on how things will unfold. So first, there's one thing I would like to clear up. Even though this course is called Anime Effects in Houdini and Nuke, we're not just doing anime style effects. Honestly, this could have been called just stylized effects in Houdini because really that's what we are exploring. But I picked anime effects because it sounds cooler and because the style we're aiming for leans heavily into anime influences. But the techniques you learn here aren't locked specifically to this style. You can really apply them in a bunch of different projects, even realistic ones if you adapt them. Now, the first question you might ask yourself is why Houdini and Nuke? So if you know me, if you're familiar with Voxide and what we do, you know we're really into Houdini and Nuke. Really, these tools are absolute titans in the VFX industry. Any movie that came out in the last 15 years, or maybe even older than that, uses Houdini and Nuke in some capacity. Houdini will have the highest flexibility when it comes to building effects, and Nuke can take whatever we render from Houdini and really push the result and even take the result in completely different directions, which is a lot of what we'll actually do in this course. Now, I think Houdini is self-explanatory as it's by far the best when it comes to creating and designing 3D effects. But what role does Nuke play specifically? Now, first of all, if you don't have Nuke already, you will be able to follow along with a free version of Nuke, which is Nuke Non-Commercial. At the time of recording this video, Nuke Non-Commercial pretty much has everything the paid version has, with very few limitations, and you can even export full HD renders without watermark, which is really great. So I will highly recommend you get a free version of Nuke if you don't have it already, and you can follow along with this course. There might be a couple of tools and gizmos that we will use which are only available for the paid version, but these tools will have free counterparts to them which you can use, and you will get probably 99% of the same result. So it's really just a couple of tools which will not be available for the non-commercial version, but again, with the free version, you will be able to follow along just fine with all of the projects within this course. So this course will be heavily focused on compositing. When it comes to stylized effects and NPR rendering, post-processing is the name of the game. We essentially render something as we normally do in 3D. Then through compositing, we can completely change the look and feel of the final result. Now, you might already be familiar with stylized rendering, and you might know that we can apply these kinds of effects and looks directly in the rendering. So this is usually done by either changing the material, so directly changing the shader, or we can manipulate lights to achieve certain looks. And what we'll be doing in Nuke is pretty much the same thing. We'll take AOVs and render passes and rebuild the materials and shaders in a very specific way to get this stylized look. The advantage of doing this in Nuke rather than directly in rendering is first of all, the iteration speed will be much faster. Because the renders are already baked, we don't have to wait for the render engine to restart the render for each small change that we do. And especially if you are working on a larger scene with heavier elements, with a lot of geometry and information, you can imagine that having to wait 1 or 2 extra seconds for every time we want to make a small change, these extra 2 seconds of waiting in between changes can really add up, and it's honestly just annoying to work with. The second and much bigger advantage of doing this directly in Nuke is that we are inside Nuke. So we have all the tools that we would normally have if we were to do this directly in rendering, but then we have a lot more than this. So we have access to advanced grading tools, we have all sorts of distortions, blurs, and really everything Nuke has to offer. On top of this, Nuke also has like a million gizmos that were created by the community and developed over years and years of work. So when it comes to post-processing, Nuke is really the best tool for the job. Now recently Side Effects has revamped COPS into what they now call Copernicus. So really compositing operators. Now this is a super powerful system, and a lot of things that we do in Nuke we can do in COPS. The thing with this new version of COPS is that it's still not up to par with Nuke. We have to keep in mind that Nuke was developed over 30 years or so, I don't even know, while COPS is really just 1 or 2 years old at this point. So it does have a bit of catching up to do, but from what I've seen so far, COPS looks extremely promising, and I'm sure in the future it will only get better and better. But right now, a lot of things are still a little bit awkward to do in COPS. Simple things like pre-multiplying, un-pre-multiplying, just moving and shuffling channels around. It can get a little bit messy, and certain effects might require 3 or 4 nodes in COPS, while it's only going to be 1 node in Nuke. And we still have to take into account all the other stuff, like having a bunch of gizmos contributed by the community over years and years of work. So it still at this point has a major advantage over COPS, I would say. So for this reason, I chose to use Nuke for the compositing part of this course. Regardless, all the techniques that we are going to use are not going to be exclusive to Nuke. You will be able to apply a lot of these techniques in COPS if you want. So as COPS will continue to get better, everything that we learn in Nuke we will be able to take over to COPS eventually. But for now, Nuke is still the best tool for the job, and we want to use the best tools, so this is why I chose Nuke. What COPS excels at, however, is building and designing effects from scratch, so without any base render. So for example, in our Demon Fire project, this fire right here is actually created entirely from scratch in COPS without any simulations, without any geometry really. It's just applied on a flat grid, as we'll see in this project. So I think this is actually where COPS can outshine Nuke. And this is why we'll have entire sections of this course completely dedicated to COPS. So hopefully this cleared up some questions you might have, and now you understand the reason why I chose these tools and this workflow specifically. And now we can get back to the actual course and let's see what we are going to learn. So the first module will be a fundamentals module, and we'll do an overview on the techniques and workflows we are going to use throughout the course. And we'll break things down into the core elements that make up a stylized render. So the first thing we'll take a look into will be cel shading and outlines. Now, cel shading is really the heart of stylized effects, and we will explore different ways in which we can create this cel shading look, and when and how to use these different cel shading methods, and also how to push them a little bit beyond what's normally seen in the style of rendering. And for each of these techniques, we will have just a few small projects that we can directly apply the techniques to and just get used to these tools. So cel shading will be a huge part of this course, and something that goes along cel shading will be the outline. So we will take a look at different ways in which we can achieve outlines, and also how to introduce a little bit of texture and even movement to our outlines to make it actually feel like something that's hand-drawn and just make our renders come a little bit more alive. So this will be the first fundamental module, and the second one will be setting up the effects. So this is where the Houdini part comes into play. It matters quite a lot the way we actually set up the effects in Houdini, and also the way we render these effects. So we will dive a little bit more into this topic when we actually get to this lesson, but essentially you can either render the effects as geometry, so as a mesh, or you can render them as a volume, or you can even render them as points. So these are really the three main ways in which you can render effects, and we will take a look at each individually and try to apply this cel shading to them, and we will see the advantages and disadvantages that each of these methods have. And finally, we will also explore a topic on how to achieve depth in your renders. So a lot of what we'll talk about in this lesson, you will be able to apply these concepts even to realistic renders. And really achieving depth is a super important project when it comes to any kind of rendering, not just stylized rendering. We will explore some techniques on how to get a flat render that doesn't have any contrast, any point of interest, nothing at all. And we'll see how we can turn it into a render that actually feels 3D and actually feels like we have depth in it. So we will explore a lot of important concepts here, which we will carry over throughout the rest of this course. So after we get comfortable with the tools and the workflows, we will start with our project-based courses, and we will take a look at our first one, which will be this Demon Fire project. So we will have 5 shots in total, and each of these shots focus on a specific technique or concept, and each of these will slowly ramp up a little bit in difficulty, starting with the first one. So in the first one, the Demon Fire project, here we will explore the cel shading. So we will try to push all the techniques we've learned in the fundamental lessons and apply them in a real scenario project. And I also want to show you how to create this cool fire effect directly in Cops. So just like I mentioned earlier, this is where Cops truly shines, to create these stylized effects completely from scratch. So we will explore a lot of what Cops has to offer. We will also build a custom tool here to help us with our cel shading. This really won't be an advanced tool. We're not going to write a custom script or anything like that. We're just going to essentially group a lot of nodes together and expose some properties at the top level, just so it makes our life a little bit easier. And this custom tool we will be able to use throughout the rest of our projects as well, and it will just speed things up by quite a lot. Now moving on to our second project, this will have a focus on generating outlines. So we will see first of all how to create these outlines and how to add this movement and texture to the outlines to really give us this sense of speed and just overall movement throughout the scene. We will also explore a little bit of shading and adding certain graphite texture to our shadows and other techniques, and we'll also be exploring Cops a little bit more. This wind tunnel created here is also going to be one of these effects that we create entirely in Cops from scratch, so it's not a simulation. It's going to be a noise layered with distortions and all types of good stuff. So we'll see how everything works when we get to this project. Then on our third project, the focus of this one will be setting up the effects, meaning that we will create the simulations here in a rather specific way that allows for this stylized look to happen. Of course, we'll also explore cel shading and outlines and all the other stuff we've learned already in the first 2 projects. And we will also explore layering as a concept. So if we take a close look here, we will see when we get to this project that this top half, let's maybe change the color here. So this top half of the dragon is one layer. The eyes are actually one layer by itself. Everything is rendered separately and layered together to achieve a very specific look. So this is what we'll explore mostly in this third project. And then we will move on to our fourth project. So here again, cel shading, outlines, will carry the techniques we've already learned, and we will also push some of these in new directions. But here the focus will be creating the geometry at the sub level, so not with really standard simulation methods. So these stripes here or ribbons we will create mostly through geometry with a little bit of help from simulations. But a lot of this workflow will actually resemble workflow that you would see normally in real-time effects. So a lot of these techniques we will borrow from real-time effects, and also the effects that we do here directly in Cops. These are also going to be borrowing techniques from real-time effects. And this is really why I wanted to create this course, because stylized effects are really a combination between traditional Houdini simulations, real-time effects, and taking all of this and pushing it in compositing. So we're really just blending a lot of mediums, a lot of different workflows, And really it's just going to be a lot of fun, and it will allow for the most amount of creativity that you can have. So this will be the focus on our fourth shot, and on our fifth and final shot everything comes together here. All of the things that we've learned in the first four shots we will apply here. So we'll take a deep look into cel shading, into outlines, into layering effects, into creating effects at the sub level or through simulations or through cops. So everything will come together in this final shot. This will be the final boss. So this shot will require quite a bit of work, but we will already be familiar with everything if we do all of these projects in order. Now, with that being said, if you are already an intermediate or advanced user, you might be able to just get to this shot directly if you want to. So the order here is not really set in stone. It's not super important, although I will recommend going through all of these one by one. But if you are advanced enough, you will be able to just pick any scene that you want and you will be able to follow along just fine. All of these modules are designed in a way to be able to follow along, and of course all of the assets will be provided, so you will be able to follow along with the Houdini part, with the Nuke part. If you just want to follow along with the Nuke part, I will include all the renders for all of these shots as well, but of course I will show you the Houdini part as well. So how to set up all of the simulations and all of the renders and lights and everything, render passes, everything we need. So this is it. This is how the course is structured, and now we can start with the fundamentals. We will dive into the first lesson and we will take a look into cel shading and outlines. So I will see you there. Now, the way that we are going to do cel shading is going to be a little bit different than the traditional way cel shading has been done. And first, I would like to show you this traditional way of doing cel shading. So here I'm inside Houdini, and let's just jump over to the Solaris stage level here, just so that we are dealing directly with rendering, and we can just drop some geometry here. We can use our test geometry rubber toy, and we can see this here. So we can just simply use a light here. I'll just append a Karma physical sky, and if I press Shift R, we should see our render here. I'll just set this to Karma XPU. I'll press P to bring up my options here, and I'll just increase the exposure and maybe play around with this sunlight direction here, and also I will turn off render light geometry. So the first method of doing cel shading, if we want to apply this as a post-process effect, we can just export this render to cops. We can use the new tools in the latest cop version to process this render, and from here we will also do a Karma render settings node. We'll set this to XPU as well. We don't really need on the other settings for now. We can keep everything at the default, but what I will want to turn on is going to be denoising, as this will be pretty helpful when it comes to this cel shading look. But let's actually for now keep off the denoising because I want to show you how this works. So if we do a cop network from here, as long as we have this and we have something rendered here, if I now stop this render and dive inside our copnet, if I do a slap comp import, and we will just click this add AOVs from last render, and we should have now the last image that we rendered. We can go to the composite view here because it's going to be easier to work this way. And the first thing that we can do to achieve cel shading is going to be to grab our beauty here, and we can do a quantize. And what this will do, if we look at this, as I decrease the segments here, we can kind of see how our image is being kind of split into different tones. So the less segments we have here, the more this effect becomes more obvious. So essentially what this is doing, this is just going to sort of flatten the pixels within a given range, meaning that if our pixels values go from 0 to 1 and they have all of these float values in between like 0.1, 0.2, 0.3, the quantize will sort of clamp the pixel values, it will sort of round them up to a given value. So a pixel value of 0.35 might become a pixel value of 0.3. So this is how we will get this layer separation in our image now. And we can see we do have a lot of noise in this transition between the layers. So this is where the denoising will come into play. So if I go up and I go back to the Karma render settings here, let's maybe do another render. I will go to the image output here, and inside filters I will just turn on NVIDIA Optics Denoiser, and we will run another render. We'll give this a second. So now we should see that our pixel values are a lot smoother and we got rid of this noise. So if I now stop this render and go back inside our ComNet, we can go to the composite view here, and we can see already that this will be automatically updated. We can see that we no longer have this noisy transition between our pixel values here. So now this is starting to look a little bit closer to the cel shading that we are after. And this will just bring up the first point about this cel shading look that we're going for. Denoising and blurring will be key factors in determining the look. So especially if I were to also blur the image before we do our quantize, if I drop down here a blur and place this in between, we should see that as I start to increase this size, we will get an even smoother transition between the layers here. The problem here is that this will overall remove our shape reads on the character here. So the higher we go in our blur, we will get smoother transitions between the pixels, but we obviously lose the main shape of the character. So it's going to be a challenge for us in trying to find a right balance between denoising, blurring, and somehow bringing back the original shape of our character. But these are just some ideas for now. This is going to be the first way that we can do cel shading with this quantize, and we can do the same kind of effect in Nuke. So if I were to export our image here, I'll just use a ROP, let's do ROP image output, and I'll just export this real quick. So I'll just export this as an EXR, and I will just load this file in Nuke. So we'll do a read node here, and let's point to our render, which is going to be this. And the way that we can do this quantize effect in Nuke, we don't really have a quantize node. There might be some gizmos available on Nukepedia that can do this, but essentially what we need to do is, if we inspect our pixel values, we can just multiply the values of our pixels. So if I were to sample a region over here, we have, let's just look at the blue channels, we have 0.6. So if I want to kind of clamp these values at 0.6, or maybe say that 0.6 just becomes a value of 0.5, we can do a grade node and we can increase the gain here. We can just push this all the way. Let's maybe push this up to 10, and we will just round these numbers to their whole value. So 6.1 will become 6, 0.9 will become 1, and 0.57 over here will become 1 as well. So we can just do this with an expression, and we will just say that our red channels, we can round to the next whole number. So let's do Cel, and in between parentheses we'll do R. So now our 0.56 value for the red channel will become 1, and let's do here Cel for the green channel, so G, and then we'll do Cel for our blue channel, which will be B. So now we have 1, 1, and 7, and we can kind of see this transition now between the layers here. Now all we have to do from here is drop down a grade node and grade this back down so that it matches our original image. So we can do something like this, and we can actually just link it to our first grade node. I'm not gonna do this right now because this isn't really the method that we're going to end up using, but since this is a factor, a multiplier of 10 here, this will mean that this gain value here, our second grade, will need to be 10 times less the amount, so 0.1. We have some problem now with the edges, but we can just grab the alpha from our original image with a copy channel, and we can do a pre-mult. Again, I don't want to spend too much time going into this setup because it's not going to be the final setup that we're going to use, but just to illustrate that you can do this sort of quantized effect in Nuke as well. And now essentially, if I wanted to have less layers, we can just decrease our original gain value on the grade here. So if I were to gain this down, we will see less and less layers happening. Of course, we will have to adjust our grade here as well. So our second grade node to match this, but we can kind of see, hopefully we can kind of have an idea on how this effect will work. You can also experiment with doing a floor value here instead. So if we do floor instead of ceiling, this will round it to the lowest whole number, and this will also give you a cool result. And we can kind of see this here. So this is with the quantize. And the second method that I want to show you, if we go back over to Houdini, the second method will be by remapping the values that we get from the image to a gradient. And the best way to do this is to use the facing ratio of our geometry. So if we want to do this directly in the render, if we go back to the scene view and I go up, we can do this directly on the material. Now we already have a material for the rubber toy here, so I'm just going to do a SOP create over to the side and start off a new chain here. Let's dive inside and let's just do our rubber toy, but we will not add the shader, and let's also disable the UV display here. So now this geometry will not have a material, meaning that we can go up and we can create a new material. We'll do a material library and we'll step inside, and here let's do a karma material builder, and let's just name this one shader or something like this. And let's go up and autofill materials and assign to our geometry. Here we'll do slash and we'll choose our SOP create, which is our rubber toy. So if we go back inside, we can go inside our material settings here. We won't be needing displacement or this material properties. And if we do test render here, let's check that our material is working. So we can see that this is now applied. And for this facing ratio, let's drop down. If we do facing ratio here, we will have MTLX facing ratio with this Houdini in parentheses. Let's drop this here and we'll apply this on our emission and emission color. We'll go to our surface here and we'll set the base to 0 and specular to 0 as well. And we'll go to the emission and we'll set this to 1. So now for this facing ratio to work, we need to import our two vectors, and the first one is going to be the normal. So we will do an MTLX normal, and this will just grab the normals of our geometry. We can see the space by default is set to object, which is what we want. We'll plug this in the second input, and for the first input we need the direction of our camera. So this is how we determine this facing ratio. It's really just a dot product between the direction that our camera is pointing and the normals of our geometry. So let's do a karma ray import, and here we will choose from these presets. We will do, let's use ray direction. So this is the one that we need, and we'll plug this over here. So if we do a test render now, we can kind of see this in action here. We can see that essentially all of the normals of our geometry, which is directly aligned with the direction of our camera, will have a value of white, and everything that's pointing sort of away from our camera will be darker. Now we can just filter this through a ramp. So if we do a karma ramp constant here, we can now give this some different colors. So for example, I can choose a blue color here for our dark values, and for our bright values here, let's choose a darker blue or something like this. So we can kind of see we're getting now really close into the stylized rendering look. And the only thing here that we have to do to make this into a cel shading is change the interpolation of our gradient here. We will use constant. So now if I grab this blue dot here and push this over, we can kind of see the effect that we get. So now this is starting to look a lot more stylized, a lot more like a toon shader. We can also introduce, of course, as many colors as we want. Maybe we can do another yellow, or rather white over here. We can push this forward. We can do something like this. And this is really the traditional way that cel shading has been done. And we can see that there's really a lot of control that we have with this. The problem with this method is that we are completely overriding the base colors that we started with. So if we wanted to take the colors from our actual render as we have over here and use this remapping or a gradient method, we kind of lose all of the color information from our original material. So this is one of the drawbacks of this technique. And just one more note, we can also do this, and this is what we'll actually do in our main projects, is doing a variant of this technique but apply it as a post-process effect, so not directly within the shader. So if I were to go back up, we can go back to our Karma Radar settings here, and we can export this facing ratio as an AOV. So if we go in the image output here inside the AOVs, we can go all the way to utility, and we can turn on here, we have this facing ratio. So if we do a test render, we can see this now over here, and it gives us the exact same result as we had earlier through the material. But now, since we are rendering this, if I go back inside our CopNet, we can go to our slab comp import here, and let's reload image and let's add AOVs from last render. We'll click this again, and now we have access to our facing ratio pass. So if we go into composite view here, we can actually preview this facing ratio. We can select this over here, and it's not really showing. It's probably showing in the scene view here, but it's just this flat plane weirdly positioned into space. Let's maybe go back to composite view, and I think we can also select this from over here. All right, but if we go back to the beauty here, we can just grab this facing ratio, and we can just run this through the same kind of ramp. So if we do a ramp RGB, we can use this as the position, and if we preview this, let's also bring the size reference. We'll point this to our C over here just so we have the same resolution. And now of course we can select our colors here. We can use a blue, and let's just set our ramp here to linear, or actually we need to set this to constant, and now we have the same kind of result that we had earlier. We can introduce one more over here maybe, and let's play around with our values. We can also remap our values probably before we plug this inside the position to have a little bit more control, but this is just to illustrate some of the options that we have. So now this is applied again as a post-process effect. The advantage of doing this inside a COP network is that if I go up and if I go back to the scene view, I can just quickly switch around, do another test render, and this will be updated in our composite view. So this is really cool that we have this really cool, really fast feedback, and we don't have to re-export images all the time. But with that being said, this isn't really the bottleneck that you will have when going for the stylized look, because when you figure out the camera and the timing and the animation, you don't really have to go back to readjust certain things, or at least you don't really have to do this constantly. So it's not really going to give us that much of an advantage in this case. And again, we can do the same thing in Nuke as well. Let's maybe go back to our CopNet, and let's just export our facing ratio over here as an image. I'll just replace this over here, and let's render to disk. And hopefully now if I go back inside of Nuke, I can clear cache, and let's see if we can read in our other image. So I think I need to do a shuffle in this case. Really, I just want to bring in the facing ratio. Let's just plug this inside the alpha, our beauty essentially, and if I press A, we should see our facing ratio pass. All right, so this is what we have, and we can use an ST map for this, and we can point our ST map to our alpha, and in the UV channels here we will choose alpha, and for the source, this is where we can create our gradient. So we can use the gradient editor for this, and this is a custom gizmo that's going to come with the Nuke Survival Toolkit. So you have to make sure that you have that installed in order for this to work. But again, this isn't really the method that we are going to use in our own projects, but this is just to illustrate that you can do this inside of Nuke as well. We'll point at the source over here, we'll go to our ST map result, and now if I press A to go back to RGB view, we can see, we already see our gradient over here, and we can just choose the interpolation here to constant. gradient, and we can now play around. It's going to essentially just map all of these values to our black and white values, to our gradient over here, and it's essentially exactly the same thing as we had earlier inside of Houdini. So these are just some of the methods that we have available for us when it comes to cel shading. Again, the problem here is that we are completely overriding the colors from our original render, and we don't really have this over here because I've saved over this image, but this is the problem that we have to solve. We have to somehow keep this nice transition between our values, but we want to also incorporate the colors that we have in our base renders. So with the next lesson, let's take a look into how to set this up, and let's create our first sort of mini project to explain the main way that we are going to do the cel shading. So I will see you there. So let's dive into our first cel shading example, and I have prepared a very simple render here, and you can also download this render and follow along if you want. So it's going to be just a simple helmet with some materials applied to it, obviously, and for our lights we just have a skylight that travels around our helmet, so we have this kind of animation. We didn't necessarily need any movement for or rather an animation for this example, but I just wanted something that moves as well so we can see our effects in action. Now for our main projects, I'm going to show you the Houdini setup as well, so how to set up the renders, how to set up all of the AOVs and the lights and everything else. But in this case, since it's a very simple setup, I don't think it's necessary to go through all of the Houdini steps. You can just grab this render as it is, and we have some of the usual AOVs that we need. So we have our normals, our global position, our AO, and we can also see that we have separated our combined diffuse passes per lights. So we have our combined diffuse sun, we have our sky, and our reflection sun as well. So all the usual AOVs that we normally export from Houdini. Let's go back to RGB. So this will be our render, and let's take a look into how we're going to set up the cel shading. So what we want to do is similar to how we set it up with the ramp in the previous lesson. We want again a hard transition between different stages of our light intensity. So let's say in this case, if I were to drop down a shuffle, let's go ahead and in the node here, I will do between brackets, I will type value in 1, so we know which channel or layer we are shuffling in. We can choose here, let's choose our combined diffuse sun. So we have this nice gradient here. We can clearly see the intensity fall off here. So this will be perfect to illustrate the first step in our cel shading. So what we want to do is, first of all, I would like to just work with one channel. So I will just grab the red channel and I will place this inside the alpha. And if I press A, we have this. So essentially we are just working with single values that in this case go from 0 to 1. They don't really need to go from 0 to 1. They can go between any kind of range, but it will be important that we just work with one channel, in this case the alpha. So again, I'm in the alpha channel here. You can just press A. If we drop down a grade node, let's run this over the alpha here. So I'll set the channels to our alpha, and we can increase the contrast. If I were to decrease the gamma, I can also decrease the white point here. So we can see that by increasing the contrast, we will start to get this hard transition between the stages of our ramp. So we can push this even further. We can also push the black point a little bit until we can see we don't want to go to the invert size. So let's see, somewhere around this part is where we would want to be in this case. And now if I play around with the offset, we can see that as I decrease the offset, we can filter out different regions of our ramp. So I can lower this until we filter out smaller and smaller parts, and this is how we can create this delimitation between all of our layers. So again, we want individual control for each of our layer, but the thing is that by doing this with a grade node, this is a little bit hard to control, and we will need different settings depending on what layer we are using. So if we were, for example, to shuffle even another channel here, so if I were to bring in the green, we would have to readjust the grade values here, the white point, the the black point, the gamma level, and so forth. So we want to do this in a slightly different way. We can get rid of this gray node and we can drop down an expression node. And what we want to do is just compare our alpha channel with a value. So in our alpha channel over here, our fourth layer, if we do A, this A will grab the current pixel value of our alpha. And if I were to just compare this with a different value, so if I were to do a less than sign, and let's just start with a value maybe of 0.3, we can see that this is what happens. So all of the values that are less than 0.3 in this case will receive a value of 1. So it's going to be this side of our helmet over here, and all of the values above this 0.3 will receive a value of 0. So if this condition is true, it's going to be 1. If this is false, it's going to be 0. We can also do the inverse of this, which will probably make a little bit more sense. So if I do A bigger than 0.3, we filter out this side of the helmet. And now if I were to increase or decrease this value, we can see we can filter through different regions of our helmet, and this is exactly what we want. And we can simply link this value over here. We can just create a custom slider which we can control. So if I were to right click anywhere inside the property windows, we can go to manage user knobs, we can do add, and we will choose floating point slider. We will give this a name here. So the name is what we'll have to reference inside our expression. So I will name this one trash, like this. And for the label, I will name this one threshold. So this is the one that we will have to remember. Let's hit OK. Let's hit done. And we have this slider now. And to link this value inside our expression, inside here, instead of 0.1, I will do in between brackets. We can do value and we can type the name that we set to our custom slider, which will be trash. So it's the first name that we created, not the label. And let's go ahead and evaluate this. And now, since this expression is set, if I go to the user knob over here, we can see we can control this transition with a slider. So this is now how we can control each level of our layering. So with this expression node now set, we can reuse this throughout our comp. And let's go ahead and we'll go back from the beginning and we will create the first base layer for our render in sort of the same way that a normal drawing is done, meaning that for our first base layer, we will just use a flat color to fill up our image, and on top of this we will just add layers of highlights and shadows to make our object 3D. So again, to make our first layer, let's start with a fill color. We can do something like a constant here, and we can just give this a little bit of brightness, like so, maybe something like 0.1 in this case, and we will want to copy the alpha from our original image. So if we do a K, we'll point this to our render. We'll do Shift X, so it's copying the alpha from A to B. And now if I press A, we have the alpha of our render. And if I do a pre-mult, we have this over here. So this can be our base layer, our level 0, so to say. And using the alpha that we create over here, we can now layer in more and more information and as much information as we want, essentially. So let's go ahead and actually I'll grab this render. Let's do a dot over here, hold down Control, add another dot, and let's organize things a little bit. So now, for example, I can just grab the same setup here. I will just copy and paste these nodes. And let's say that for this color, I'll do something a little bit brighter. And for the alpha, I will grab the alpha from this expression that we created. Let's do another dot here. And maybe I'll just bring these down below like so. And now if I look at this result, we have this. So now we can essentially just do a merge and we can place this on top of our base render and we can start to see slowly how this will work. And now I can go back to this constant over here and I can increase the brightness if I want, and we can do one more layer here. Let's do 3 layers, which is more or less what's going to be needed for this cel shading. You will rarely want to go above 3 or 4 layers, honestly. and we can just grab another dot over here. Let's grab all of these nodes. Let's paste them down below. Let's add another dot here, and for this one we can do another merge, and we'll merge this on top as well. And let's go ahead, and for this one we can just go, if we go to the result of the pre-mult, we can go to the expression, to our threshold value over here, and we can just increase this so we can get a different version, or rather a different area of our highlights here. So we can do something like this, and we can just increase the brightness. So we'll just pump this up a little bit, and now if we look at the result with everything on top, we have this result. So what's cool about this is that first of all, we can just go to our expression here, and we can control exactly where this transition happens. So this is really important. We can also check this over here. We can control this, and we can see this feedback in real time. So this is very important to completely art direct our look. But even more important is that now we can do any individual edits that we want per layer. So if I were to go to our first layer over here, let's maybe make some more room so it's nice and organized. We'll do something like this. And again, if I were to go to this first layer, what we can do is, for this expression, for our alpha channel over here, I can press B to drop down a blur node, and we can just increase the size. And we actually want to do this blurring before our expression, so we have this hard cutoff. So if I were to just disconnect this and place this over here, we can start to see exactly what's happening. Let's preview the result from over here after our pre-mold, and I'll press A so we can see this with the color. If I now increase this blurring amount, we can see that our transition will start to get more and more smooth. We can actually preview this with our first layer as well, and we can see the result that our blurring will do. So blurring and denoising will come a lot into play when creating these sorts of transitions, and they will also be helpful just in general to crush the detail that we get from our base render, to get rid of any potential noise, and to just smooth everything and give it this sort of hand-drawn feel. And hopefully you will agree with me that this is now starting to look a lot more like an actual drawing. So if we were to preview this with our second layer as well, let's add another blur here as well. We'll push this until we get a cool result here. And we can also, on the note of denoising, if I wanted to, we can go to the combine diffuse here. We can drop down a denoise. Let's also try this. Let's increase the sample region, and we'll place this somewhere around our render. Let's increase the smoothness and increase the denoise amount. Let's maybe push this all the way to 100, and let's also increase the luminance blend, and we can see the result that this denoising will have for us. The problem is that the denoising doesn't work by default on the alpha, so we can do another shuffle here, and we can just grab our red channel and plug this back inside the alpha. So we have to remember that our expression only works on the alpha, and going forward with our other projects, we will heavily rely on this alpha channel, because again, we just want to work with one channel in order to get this transition. So now if we look at let's actually disable the blurring, and we just have our denoise on the alpha. So if I go to the expression, we can see that the denoising indeed does work. So if I were to disable this, we can see exactly the results that we get. The advantage of the denoising is that it tends to preserve some of the hard edges we might have. Let's go to our shuffle here, and we can see that this line over here, for example, and the shapes of our eyes. So where the image has very high contrast between pixels, it will sort of try to retain that sharpness and smooth everything else. So it's a little bit different than a blur, and it will have some use cases, and we can see the result that we get. We can probably push this even further. Let's see what we get. So as I start to increase the denoise amount, we can kind of see how this will affect our layering. In this case, I will probably just go with the blur. I want this nice smooth transition, but this is just to give you an example of how useful this denoising can be. And we will use this in different ways throughout this course either way. So again, let's go back to our final result over here, press A. Maybe I can go to the expression here, I can push this even forward, and we can see also that this will work with any animation that we might have. So already I think that we are getting a pretty cool result. Now, one important thing that we can do here is, since we have these as separate individual layers, we can bring back some of the original color from our render if we want to. So first of all, for our level 0, for our first layer, our base layer, instead of just using a constant color, I can maybe use some of the colors from our render. Of course, if I were to just point the B channel here instead of our constant, and I would point this to our original render, we just get the same result. But now, if I were to just blur this by quite a lot, if I were to increase this, we can see that we do get a little bit of the colors that we had originally, but we will get the sharp outline of our alpha. So already, if we plus these other layers on top, we should have a better result. And because we want our first layer over here to be the darkest layer, let's go ahead and also drop down a gray node, and we will take now some creative decisions to maybe make this base layer a little bit darker, just to highlight our other layers a little bit more. So we'll just darken this a little bit. We can also we can see that this blurring here, when we apply this, it will kind of darken the edges a little bit. We can also use an erode before our blur, and if we push these values up and then use our blur, we can see that with this dilate we get a little bit closer to our original color. So now if we look at the pre-mold, we have this result. But still, I would like to darken this a little bit. And doing it this way, it's really cool because we end up with a cool gradient on an otherwise flat color. So we can see that if I were to just drop down a constant, everything would be the same color. But in this way, we have some nice smooth gradients. We have a little bit more of an interesting look. So you can see these kind of gradients in a lot in modern anime. So I think in the last years, especially if you look at something like Demon Slayer, you will find these very subtle gradients very present on all of the characters, on all of the renders. So it just adds a little bit of depth to the color and overall just creates a better result. Now this will be completely up to you if you want to go for the flat look or this kind of gradient look. I wouldn't say one is necessarily better than the other, but in our case, for most of the projects that we'll do, we will rely on this kind of smooth gradient. So anyway, this will now become our first layer, and if we want for our second layer over here, we can just go to this merge result and we can set this to screen. So now this will be our first highlight, and for our second highlight, we can also experiment here. We can set this to screen or even plus, and we can see now that this is the result that we get. So we can also control this with the mix values over here. We can control the constant values, and if we want, we can bring the colors from our original renders into these layers as well. So let's say that we want to bring some of our render into our final highlight layer, which is going to be this one over here. If we grab our render, let's do another dot. We can, instead of this constant, again, we can just point to our render. Let's maybe grab this and point to our base render, and we can already see this over here. So if I wanted to, we can also drop down a gray node. We can increase the contrast here if we want, and we end up with something like this. Now, obviously, this is looking a little bit silly, but this is just to show you that now we can introduce colors and even details from our original render, and this is the power and flexibility with this approach to doing cel shading, where we break up each individual layer into its own separate thing, which we can treat individually, rather than creating the whole ramp over the whole object or using the quantize method. This method will provide, I think, the highest flexibility and amount of control. So we can also grab the denoise maybe from over here. I will just copy and paste this before our grade on our B pipe over here, and if I turn this on, we can see we get rid of some of these highlights. So now maybe this will work a little bit better, and we can also go to our grade over here. We can play around. So again, with instead of this constant over here, I can also maybe do the same thing. I will grab the denoise, place it above, and place the B pipe over here, so we can bring again some of the details from our original render. And maybe we can do another grade over here. We can gain this down, and we can see the results that we get. We can also do individual denoising per each of our renders here. So maybe I want different settings on this layer, and now we have this option to do this. Or maybe we can just use a blur here, and we can also crush some of these details with this blur as well. I think honestly with this denoise we do get kind of a cool result. Now a lot of these details we will be able to bring back with the outlines, which will be our next lesson, but we can still use the blur, the denoising, and get a really cool interesting result. And again, let's get rid of this denoising over here. We have the blur that controls how much detail we get on the transition. We can maybe crush this even more. Let's go to our first one. Let's try some of these settings over here. And of course we don't necessarily have to mix these values with a screen operation. I can keep this as over, and it will completely overlay on top of the base layer. So this is also an option that we have now. We can of course just increase the blur in this case, maybe play around with our grading adjustment. Now this doesn't really look all that great. Honestly, in this case it's better to just go with a simple flat color if we are using a screen operation. Let's maybe increase this a little bit, and let's set this back to screen. Right, and now we can control this. So it will depend on the render, it will depend on the model, the geometry that you're using. And on the note of geometry, now in this case we are using something very traditional. So this would be a normal type of geometry. We can see we have a lot of detail in our shadows. We have all of these scratches, we have all of this bump information, we have just overall a lot of detail, which doesn't really jive that well with this kind of stylized effects. But this will be part of the challenge with this course, is taking realistic renders and only through compositing turn them into cel shaded, hand-drawn kind of style renders. But it is something that needs addressing in a lot of cases. For the cel shaded look, for anime type of effects done in 3D, you would have to create the geometry in a specific way with not a lot of detail on the geo, and then especially the materials as well. You wouldn't necessarily use all of this roughness information, all of these scratches, all of the bump texturing, and so on. So it's just one of the points that I wanted to address. It is pretty important, the geometry that you're actually rendering, but we will do our best, and it's just going to be a fun challenge to try again to get super realistic renders and turn them into this hand-drawn style render. So hopefully things will make a little bit more sense now in terms of how we are going to set up the cel shading. Let's go ahead and also replace this back here. Our third level here will just use a flat color as well. Let's get rid of these from here. Now, one more thing that I would like to address or just show you real quick is on the note for the gradients. Again, this type of gradients you'll see all the time in anime if you look close enough, and instead of just using a constant color over here, we can just simply do a ramp, and I can point this in the direction that our light is facing, for example, because this will probably make more sense, and we can use this as our fill layer here. So when we look at the result here, we can maybe make this a little bit more obvious, but we can kind of see now this very subtle gradient on our character here. So if I were to replace this with our constant, we can kind of see this subtle gradient. So this is also something that you can do. You can just introduce these ramps that go in the direction of the light source, essentially. But all of this again is to say that by separating each layer individually, we will have control at each level, and this is what we're after to completely art direct our look. Let's go ahead and replace this back just with our constant for now, and we will probably come back to our cel shading here in a minute. But for now, we can move forward with our next lesson, which will be how to create the outlines. So I will see you there. So for the outlines, we have quite a few options which we can take, and with these outlines generally we would want to layer them in order to highlight the areas of our geometry, so our character, to highlight the areas that we are after. So in some cases you might want more detail or less detail. So let's take a look at the first option that we have, which is to just create an outline around the silhouette of our geometry. So just the edges of our helmet, in this case, nothing inside this actual helmet area itself. Now, in order to see our outlines better, let's go ahead and just create a simple background for this. If we drop down a ramp, we can create a simple ramp like this. Let's do something like this. Maybe drop down a gray node, decrease the gain, and maybe increase the gamma. Let's do something like this, just a little bit of a subtle gradient like this. And from our layer over here, let's drop down a crop node as well to contain the bounds of our comp. And if we press A, we can see we do have the correct alpha here. Probably we are overstepping our alpha boundaries here slightly. So the best thing to do here is actually to just copy over the alpha from our initial geometry. So let's drop down a copy node with K. I'll drag this over down below, and for our B layer, let's point this to our main render over here. I'll maybe add another dot like so, and I want to reverse the layers, so I'll press Shift X and I'll bring the alpha from our main render to our end of the chain over here. So if I press A, we have the correct alpha, and we can do a pre-mult here and get rid of this overstepping area here. We can now safely merge this over our ramp as well. So if I drop a merge, our B layer should be our ramp, and we can see we have a cool background now. Let's maybe go to our grade, and maybe we can play a little bit with the values here, but let's just do something like this. And now, in order to get this edge here around our helmet, we can simply point back to our original alpha. If I press A, we can just use this information here to create just a simple edge around this shape. So if I press A again, let's maybe do a postage stamp node, and let's point this back to our render, just so we keep things a little bit more organized. So this postage stamp will be sort of like an object merge in Houdini. It will simply point back to our render over here. So let's do a shuffle, and with this shuffle I will grab the alpha channel, and I want to populate all of these channels here. So I want to override them with this alpha. I will hold down Alt, and we can see now that we can just plug the alpha inside all of our channels. And now from here we can do an erode, and we can push this layer out. So if I increase the size here, we can see that we can just expand the pixels around our helmet. And if I were to drop down a merge from here and set this merge operation to minus, we can see we are left now with just this outline. We are just subtracting the original render essentially from this pushed out version. So we are grabbing this and we are subtracting this, and this will just leave us with the expansion from our dilate node essentially. So now all we have to do is drop down an invert, so we have this black over white, and from here we can just drop down a merge, and we can set this operation to, let's do multiply, and here we have our edges. So pretty simple, and now we can control the size of our edges here with this dilate size, so I can push these out or in if I want to. And if I want the reverse of this, so if I want the edges to go inside our mesh, I will just reverse the order here. So now this dilate will be our B layer, and now I can grab the size here and I will push this inside, and we have this result. Let's go ahead and undo all of this, because I want these edges to be pushing out. In most cases, I will opt for the edges to be pushed out. Pretty cool, but there are a couple of things which we can do here to improve this a little bit. So what I would like to do is introduce a little bit of noise on our outline to just introduce a little bit of texture and make our outlines resemble something that would be hand drawn a little bit closer. So what we can do here is, before this dilate node, we can run an X distort XM. So this will be a custom gizmo. So this will come with the Nuke Survival Toolkit installation. And this unfortunately will only run in the paid versions of Nuke. It will not run on non-commercial, but I will show you in a second another way that you can do this with the standard gizmos available in Nuke. But but it's just going to be a lot faster to just set this up with this simple node. And I can now play around with the noise. We can decrease the blur map, we can play around with the blur size over here, and we can instantly see a lot of variation now in our outlines. We can play around with some of these other settings here. I'll set the blur to 0, and maybe we can just play around with the distortion amount. We can maybe decrease the size, increase or decrease the blur. We can introduce more roughness if we decrease the blur map here. And overall, we just have a lot of options. And what's really cool now is that we can also animate this noise. So if I grab the Z value here and I press equal over the value, we can link this to our frame. So here I will type frame and we'll divide this maybe by 50. And we should see now, if I just isolate this layer, we will see that over time our noise will evolve and it will sort of make our outlines come alive. Probably we can do something a little bit faster here. Let's go ahead and just divide this maybe by 10, so they're animating a little bit faster. So this is the result that we have, and this will sort of mimic the way, if you imagine that these outlines are drawn individually frame by frame, we can imagine that at each frame we wouldn't have the same perfect outline. We would have a little bit of this human error occurring. So this is what, for a lot of these projects that we're going to do, this is what we will try to replicate. We will take our perfect CG renders and we will try to introduce these tiny imperfections and again this human error where we can. So we will introduce slight variations per frame, per each individual frame for a lot of these layers, not just the outlines. And we will also introduce distortions and play around with noises, again, to introduce these small perfections that when you add all of these up, it will really make each frame seem a little bit different from the last one, in a similar way to how you would see this in an actual hand drawing. So this is how we can animate this noise. And if we preview this with our reflections, we should have a pretty interesting result. We can see already that this just feels a lot more animated. It feels more alive. Probably this is a little bit too much. I can still play around maybe with the sizes here and maybe reduce the overall distortion. Just make this a little bit more subtle, and probably this will give us a little bit better result. Now I mentioned that I will show you a different way in which you don't really have to use this node. So we will use the I distort node here that's available with Nuke. But for this we have to create our noise maps ourselves. So let's go ahead and get rid of this, and we can start with here. Let's do a noise, and it's going to be this one from draw category. And right away, let's animate this. So I will grab the Z value here and I'll press equals. Let's do the same frame divided by 10 value, and let's see if this animation works. All right, so this is good. Now we will need to turn this into red and green channels in order for this I distort to work. So from here I will do a shuffle, and I only want to connect our red channels, and I will do a different version. I will copy the shuffle node and point this back to the noise, and here I will disconnect the red and just connect the green. And now we have the same noise for both of these, and we want this to be different, but we still want this to be linked to the original noise values. So when we change our size and all of the other settings over here, both of these will update at the same time. So the easiest way to do this is going to be by using a time offset. So because this is animated, if we do a time offset here and give this a value, let's maybe use something like 5, we can see now that we will have a different noise pattern here. So this one looks like this, and this one now will give us this pattern. So if we just merge these together, when we merge this with an over operation, we have this result. So we have red channels, we have green values, and one final thing that we will need to do here for our I distort to work, we need red and green values for our pixels, but we also want these values to go from negative ranges to positive ranges. So we will drop down a gray node and we will remove this black clamp option. And if I highlight an area over here, we can see we have 0.3. So by default, our noise values will go from 0, roughly from 0 to 1. And we want to move these kind of between negative 0.5 and 0.5. So we will just grab the offset values here and we will just push this in the negative space. So now we can see that some of these values will go below 1. Let's keep this roughly at negative 0.3. This should be fine. And in order to use this now in our iDistort, this has to be a channel that exists in our main pipe. So in this case, I will drop down a shuffle. Let's plug this here where we want the distort to happen. We will point this A layer to our noise over here. And in our shuffle, I will set the in layer to be A, and we will grab the red, green, and let's grab all of the channels in this case, and we want to output them to a new layer. So in this case, I will go over here all the way down below to new. We can populate the channels here. We can click on this RGBA to grab all of the channels. And for the layer name, we can just name this whatever we want. We can do something like distortion, and I'll hit OK. All right, so now our channels are connected. We can go all the way over here, and then we can see we have a new distortion layer, which is going to be this one. Let's set this back to RGBA. And now finally, we can plug our iDistort layer, and in our UV channels here, let's choose our distortion layer that we created, and hopefully if I increase the UV scale, we can see now that finally we get our distortion. So this is how this works, and if we go at the final result, we can see this now over here. Obviously we will need to play around a little bit with our not our dilate but our distortion here. Let's go ahead and set this to a lower scale, and we can go back to our grade node, and probably we can change the offset values over here so it's nice and centered. And we can go to our noise values now, and we can play around with our sizes here. We can play around with the gamma, with the gain, if we want to make this more rough or smoother. And we can see all of the pretty much all of the properties that we had in our XDistort node, but it's just a little bit more of a complicated setup. With that being said, once we have this, we can just grab this and we can just copy this entire setup. And we will use the iDistort node quite a bit as well, because it will provide a little bit of a different kind of distortion. So we will need this either way. But this is just to show that you don't really need the XDistort node specifically. You can do something like this. Now, obviously, this is maybe a little bit too much. Let's maybe decrease the size here, maybe introduce more roughness. There are some other nodes, some other gizmos, custom-made gizmos by the community as well, which has this kind of roughness to it. In After Effects, this was something called like turbulent displace. So there are many different ways in which you can approach this kind of distortion, but this is just to illustrate that if we do introduce this distortion, these imperfections, and also animate them frame by frame, you can see how much character this adds to your rendering. So these are some of the options that we have when it comes to a general outline of our object. And let's see with the next lesson what options we have to fill the inside edges of our helmet. So I will see you in the next lesson. Now, for the inside edges, we have quite a few options available for us as well, but all of these options rely really on using some of the custom AOVs that we get from our renders and using a find edges method where we essentially pick up high contrast values in our image or in our AOVs in this case, and by using an edge detect, we can create these interior outlines. So let me show you. In this case, we can grab, let's maybe just do another shuffle node, and we can point this to our same poster stamp here, or maybe we can make a new one. So I will just copy paste this poster stamp, and let's just go ahead and relink this to our main render. So I'm just going to select this dot over here, shift select my poster stamp, and then press shift Y to create this forward connection. And with Alt H, we can hide this wiring. So I'm just going to press Alt H, hide the wiring, connect the shuffle over here, and let's bring out our normal pass. So we will select our normal, we'll link these up, so our X, Y, and Z to RGB, and we have this image here. Now, if we just run a edge detect on this, let's do edge detect, and if I press A, this is where we will find our edges. We can play around now with our threshold, and we can slowly start to see the results that we get. So this will be really the easiest and the first method that I would like to show. We can also have some properties here. We can play with the erode size, with the blur size. We can maybe just get rid of some of these smaller details on our helmet, and we can end up with something like this. So this is pretty close already to what I would want. This is now set on the alpha, so I'm pressing A. If I press A again, we have this. So we just want to copy this maybe over to a background image. So what we can do from here to actually use this as an RGB image, we can just do another shuffle, and we can grab the alpha here, and let's populate all of our other layers. So now if I press A, we have this. Let's maybe expand the windows over here just so we have the channel that we are viewing over here. So I'll press A, this is the RGB, and this is how it looks. Perfect. So now from here, essentially all we have to do is just do an invert, the same way that we did with our exterior outline, and we can do a merge, and we can just multiply this over our render. I'll set the operation here to multiply, and this is what we have. All right, so pretty simple. We have also a few options here. So if we manipulate the image before our edge detect, if for example I would do a blur over here, we would start to get slightly different results. So this is something also that you can experiment with. We can also, of course, just do, if we want to tighten up our edges a little bit, we can also play around this erode node, and this erode we will or it says dilate here, but erode, dilate, it's going to be the same thing. We're going to play a lot with this node. So if I just increase the size here, I can squeeze these edges a little bit. What I would like to do instead is maybe introduce a noise for this erode size. So we can drop down a noise texture like so, and we can just link this as a mask for our dilate here. So if I go to our dilate now and increase the size, we can see we get this uneven distribution for our size. I'll set this maybe to 1, and I can go to our noise here. Let's maybe reduce the size, and let's also reduce the gain so it's a little bit smoother. Maybe play around with the gamma. So now we get something like this. So if I were to disconnect this, we can now see the different results that we get. So it's going to just squeeze the edges in certain parts of our image, and this will be the same concept of trying to add certain imperfections to our outlines, to our render. So this is the other way that we can do it, aside from the distortion method. Now, of course, we can still grab our distortion setup from over here and use it in our interior outlines as well. In this case, I probably don't want to do this, but we can still animate this noise here, and let's just do a simple expression here. I will do equals, and we can do frame divided by 10. So now in our dilate, hopefully we can start to see a little bit of movement in our edges. Maybe we can play around more with our gamma here, maybe increase the contrast, and let's try to see if we increase the size. We can do something like this. Maybe I will want to increase the gamma instead, and now if I play, we can kind of start to see some subtle movement in the interior edges as well. So these are some of the options that we have. Of course, we can still use our other AOVs as well. So in this case, I will just copy paste this shuffle node that we created here. Let's link this up to our postage stamp. I will press Shift Y for a forward connection, and let's bring in our AO and let's link this up. So we can just use this. We can already see that this can be a cool outline layer. If I drop down a gray node, I can just maybe decrease the gamma slightly. Let's decrease the white point and increase the black point. Let's maybe do something like this. Let's do a white clamp. We have to be careful when we are playing with the gradings oftentimes we will need to use this white clamp so that our pixel values don't go way above 1, which might cause some trouble when we do our merge in the main chain. So from here, if we do a merge, we can also set this to a multiply operation, and this is what we get. So we get a pretty cool result without doing really any extra work, just with a grade node. This is again some of the options that we have. Of course, now we are also overriding the background, so we don't want this. We can just grab the mask from this merge here. Let's grab this arrow and we can just point this to our render. Maybe I'll just do another dot over here. So this will grab the alpha from our render. If I grab the mask from over here, we'll point this over here, and hopefully we can see that this will fix the overriding background issue that we had. So we get a pretty decent result, I would say. One final thing that we can do here is maybe we can just bring back the eyes that we had in our render. We can grab, this will be our direct emission pass because this is an emissive layer. So let's go ahead and we'll copy this shuffle node, point this back to our render. Let's bring out our direct emission, link this up, and we can just simply merge this on top. We can do something like this. We'll set this, we'll keep this as plus, and if we want to keep the texture, we can leave it as it is, or we can just play around with a grade node. We can just brighten this up. If I lower the white point enough until we get rid of some of this detail over here, we can maybe push this even further. And now let's also do a white clamp as well. And with a second grade node, I can bring back maybe some of the original color. I can just do something like towards blue here. Let's maybe increase the blue values. We can do something like this. We can also maybe just add a subtle glow to this. So if we do a crop here, we can use AP glow, and this will be my choice for the glow throughout the course. By far the best exponential glow. This will be available with the Nuke Survival Toolkit, and it will work with the non-commercial version as well. We can just place this over here, deselect effect only, increase the persistence, and we get something like this. Maybe we want something rather subtle in this case. We can play around with the mix value. Maybe let's do something like this. So in the case for this render, I believe something like this will be fine. We can see we went to this render, so we start off with this base render, and only by using Nuke, only by using post-processing and compositing, we get to this level over here. So hopefully you will agree with me that there is a lot of potential here to do these kinds of effects only through post-processing. Now our main working projects will be a lot more complex than this. This is sort of like the absolute base level. When it comes to outline, edges, and cel shading, we can really push these techniques a lot further, and this is a lot of what this course really is about. So hopefully now you have an idea on how we will create the cel shading and the outlines. Like I said, there's really a lot of different techniques that we'll use here, and we'll explore more as we go. But with the next lesson, I would like to go a little bit more over how to actually set up the effects in Houdini. So this is before we actually export the renders out. So I will see you in the next lesson. Now, one more quick note about outlines. We have the option to create some of these outlines directly with geometry inside Houdini. And I just want to show you a quick example on how you would go about doing something like this. Now, I still think for the most cases, it's just going to be a lot easier, and we are going to get roughly the same results and control, and maybe even more control if we do this as a post-process effect. But there is potential when it comes to creating them directly in 3D through geometry. There is some potential that since these outlines will be a 3D object and we have access to the points, that we can maybe do certain operations that we can't necessarily do directly through a post-process effect. So let's just do another rubber toy for our example here, and let's step inside. Let's not add the shader, and what we want to do essentially is just create the dot product between the direction of our camera and the normals of our geometry. So we will need normal on our points. We'll set this to points, and let's create a camera. We can go up, and I will hold down Control and click our camera icon here just to create a camera. Place this roughly like so. And now we need to grab this direction of our camera, and for this we will need to import this at the geometry level. So let's grab this cam. I will Control C. I will go back inside and I will do an object merge and paste the path to our camera here. And with this, let's maybe uncheck this camera lock icon. With our object merge, I will set this into this object, so we have the position. Let's also do hide other objects, and we want this to be 1 point, so we will pack geometry before merging. So now we can reference the camera's position. So after this normal, let's do an attribute VOP. We can rename this one to set dot or calculate dot. We can reference the camera as the second input over here, and inside let's grab the camera's position. So from op input 2 we will do an import point attribute, promote the pt num value here to a constant of 0, and to get this direction we can just subtract it from our position. So let's grab our position, do a subtract, and subtract the position of our camera. And now if we normalize this, this will now be essentially this vector over here is going to be the direction of our camera. So we will do a dot product from here, and we will compare this with our normals. Let's grab our normals and let's also normalize this just in case and plug this as the second input. So if I were to plug this as our, we can just visualize this in the color. Everything turns to black, and probably this is because we should reverse the order here. So we want to go from the position of our camera towards the position on our point. So we will just grab the subtract, press Shift R to reverse, and now we get a familiar look. This is the facing ratio that we kept using, and if we go to our values over here, we can use a fit range here just so we can see this better, so we can see what happens now. We can also reverse this to make this a lot more obvious what's happening, but we don't want to use a fit range in this case. We will use a compare instead. So if I set this now to greater than, we can see that we have this hard delimitation now between the polygons that are facing the camera and the polygons that are essentially on the back face of our geometry, so they're not facing the camera. And as I increase this, we can kind of squeeze this threshold. And I'll promote the second input here just so we can control this at the top level. And what we want to do is get rid of all of our backface polygons here. So all of these black polygons, we can just do a blast node here. Let's set this group to an expression which will be at cd.x greater than 0. So if I set the group type here to points, let's delete non-selected, and we get rid of all of the points that are black. So we can now still control this. And now what we can do from here is just group all of the edges that are not connected to any other edge on the other side. So this is essentially the unshared edges. And we have a preset for this. If I type here unshared, we have this from the labs toolkit, labs fast group unshared. We can just plug this over here, and we don't want to connect the points. We want this to be on the edges. So we have this selection here. This will create a group for us unshared. And again, from labs, we have another very cool node that we can use, which will be group. If we type group to curve, it's going to be this one, labs edge group to curve. Very, very handy SOP level tool. I use this all the time. And now we can just point this group here to our unshared edges, and we essentially just create a curve from our edge selection, and this can now become our outline. So if I look through our camera, and if I template this test geometry with W, we can kind of start to see exactly what's happening here. We have this outline curve now, and we can just turn this, we can just give this some thickness. So if I go back to our curve over here, we can just do a polywire or a sweep. Let's just do a polywire in this case, and I will just decrease the wire radius here to maybe 0.02. And let's also maybe just run a color node and just push this out just so we can preview this a lot better. So here we have it again. I can template the geometry with W, and we have have our outlines. Now again, we can have the same result directly through post-processing, but now we do have access to the points. If I press Shift W or if I turn on the point display, we have access to all of the points, so we can do all of the operations that we would normally be able to do inside Houdini, which gives us quite some flexibility. Let's maybe go to our polywire here, or actually before the polywire we can run a resample and we can increase the point count. Let's maybe turn this down all the way to maybe 0.01, and let's use subdivision curves, so we just have a little bit more resolution. And we can also maybe add a p-scale attribute for our points. Let's do an attribute adjust float. By default, this will operate over the p-scale. We'll set the operation to set initial, and let's set this to a noise value. And now if I preview the result, let's go to our polywire and let's set this wire radius here to use the attribute which will grab our p-scale. So now we also have some noise on our outlines. We can go to our adjust float values here, and maybe we can decrease the element size. We can also animate this. Let's do something like this. Turn on animation. Maybe we can go to our fractal settings here and maybe reduce the roughness. And we can see now that this is animated. And let's also maybe template back our original geometry. Look through our camera, and maybe we can also just do a color here. And let's go ahead and darken this just so we can see our outlines a little bit better. So this is the result that we have, pretty close to what we ended up with in Nuke. And there are different ways in which we can achieve this kind of outline directly in geometry inside Houdini. This is just one of the ways. And again, there is some potential here when it comes to creating this sort of outline through geometry, because we then have all of the tools that Houdini provides. But in this case, for the projects that we are going to work on, we are just going to do the outlines directly inside of Nuke. We will have all the control and creative options for us that we need, but still I just wanted to add this extra lesson to let you know of this possibility of doing it, of creating outlines directly inside Houdini. Alright, so with the next lesson, let's go back to our course and let's take a look into how to set up the effects and renders. Now, when it comes to rendering effects from Houdini, really we more or less have three options. We can either render the effects as volumes, we can render them as particles or points, or we can just render them as a mesh. And depending on the way that you render the effects, you will get different results, and you will also have certain advantages and disadvantages for each of these methods. Let's go over all of them one by one, and we'll start with the volume version first. So I have prepared some renders for each of these cases. I'm just going to go ahead and load in my first render. So it's just going to be a very simple simulation like this. And because this frame range is set from 72 to 172, let's go ahead and we can just use a time offset, and let's subtract here, let's subtract 75 frames so that this simulation can start at frame 1 in our timeline. So this is what we have. And real quick, I just want to show you how to set up this effect quickly in Houdini, and also how I render this. It might not be super important in the case for this very simple smoke, but it will become a little bit more important later as we turn this into points and then later into mesh. So let's go inside Houdini and we can start with a geo container. I'll just drop down a sphere. So I'll set this simulation up in a very simple way. Let's go ahead and maybe make our ball a little bit bigger. Let's do something like 3. And let's set this to a polygon type and increase the frequency. And right away I will turn this into a volume. So let's do VDB from polygons. Let's turn off this as VDB and turn on fog VDB. And maybe I'll increase the voxel size here to 0.2. And let's run some noise over this volume. So let's do a volume noise fog. And we'll set the operation here to multiply. We can keep this as is positive, but maybe we can turn on the ramp here and we can squeeze these values a little bit just so we have a little bit more contrast. I'll also increase the element size to something like this, and I will turn on animation. So now if I preview the timeline, we also have this animation on our noise. Maybe we can remove some of this contrast in our noise, so something like this will be good for our source. Now from here we can just plug this inside a pyro solver. I will also set the voxel size over here to 0.2, and in our sourcing tab, let's make our smoke rise. So we will need temperature for this. Now we don't have a temperature source field, but we can base this on our density. I'll just change this here to density, and we don't need a flame, and we also don't need a velocity. So if I press play, we should see our smoke rising, so this is fine. We can also maybe just have our smoke expand a little bit, so we can also add a new source here. Let's set the volume source to density, and target fill will be divergence. So now I can increase the source scale to maybe 5, and if I press play, we also have a little bit of expansion on our smoke, which is good. And in our shape tab, we can also just turn on turbulence and maybe increase this to 0.3. Let's go back and let's see if this works. Alright, so everything is looking good. Let's also set up a camera now. So I'll go up and I will hit control click on the camera here and zero out all of our rotations and our translate X. Maybe move our camera up a little bit and maybe backwards, and maybe push this back as well. And in our view tab, let's do 1280 by 1280, so it's a square pixel size, and maybe let's push our camera further back and we end up with something like this. So a very simple simulation. Again, this is already rendered. Maybe the smoke is rising a little bit too fast. Now I really want to avoid having to spend too much time finessing a basic simulation, but for now let's just go to our sourcing here, or maybe our buoyancy, and we can just remove some of this buoyancy value here to 0.5 so our smoke doesn't rise as fast. So something like this I believe will be fine. Let's export this to Solaris and set up a quick render. So we'll do a null from here. This can be our out. Let's do vol, and we can just select this. Let's go over to LOPS. So at the stage level, we can do a SOP import. We'll bring this in. Let's also bring our camera with a scene import with the camera's preset. And hopefully now we should see our camera as well. And we will do a karma render settings, and let's point to our camera. Let's set this to XPU, and if I do a test render, let's switch this to XPU. We have something like this. Now, of course, if we add a light here, let's just do maybe a physical sky and turn off the light geometry, maybe increase the exposure. Now we also have a little bit of shadows in our smoke, so we have a little bit more detail. Now, in this case, it's not going to be super important for creating a cel shaded look because we are mostly going to be interested in the alpha. So if I go to the correction toolbar over here and preview the alpha channel, this is really the layer that's going to be the most important part. So in this case, for this simple example, I'm not super concerned about how our RGB channels look, so all of our shadows and everything else, but this will be an important aspect later in our main projects. So really this is how I set up the very simple render. So from here, all you will need is a USD render up, set this to Karma XPU, render the frame range that you want, and you are pretty much good to go. So this will be for the first example, the volume one. So if we go back over in Nuke, you can see that it's roughly the same over here. I will include these renders as well, so if you want to follow along, you can just grab this render that I'm using right now. And let's take a look into how we can set up the cel shading for this. And we will do the cel shading in the same way that we did for our helmet render, meaning that we will use a few layers of highlights, so a flat base layer and then a couple of highlight layers to create this cel shading based on our alpha. So again, if I press A, this is the one that we are interested in, and I'm just going to start by grabbing the expression that we had in our previous comp, meaning that this expression that we set over here with this line over here and our threshold created. So let's just grab this expression. I will copy this and let's paste this over here. And if I go to the result, press A, we can see our values now. So for our first layer, let's do something like, let's keep most of our alpha. We can do a very, very low value. Let's do something like this. And let's start by creating a constant color. And let's make sure that this is formatted to our resolution here as well. So I can just change the project resolution. Let's press S and let's choose here this 1080 by 1080. We can see that this is added as a extra resolution here towards the end of the list. We'll change it like so. And now we can just give this constant a color here. Let's press A, go back to RGB, and let's split our channels up. And let's start with something like a base color. We'll do something like this. And we can just do a merge and use our alpha as a cutout. And here we can just set this to in. So we are essentially just cutting our constant up by this alpha that we created with the expression. So this is level 1. We can from here add another gray node probably, and maybe we'll have to lower this so we can further control our colors. And let's go ahead and on top of this, let's add our highlights. Let's maybe just make some more room. Let's do something like this, add another dot over here, and let's just copy this entire setup. Let's paste this over here, and let's point this back to our render. We will do a merge and merge this on top and set the operation here. We can use something like screen in this case. And if we preview the result, we have a little bit brighter result. So if we go to our expression now and increase the threshold, we will slowly start to see the second layer of highlights here. And of course, we can go to our grade. We can bump up this color a little bit, and we can do the same for our third layer. Let's go ahead and maybe we can just grab this entire setup here and let's point back to our render. Maybe I'll grab this dot here and rearrange these nodes slightly, or maybe we can just do a postage stamp here and let's point back to our render like so. So I'll link this up over here. I'll hide the connection with Alt H, and let's link up the expression to our postage stamp so it's a little bit more organized this way, and we will be able to clearly see exactly how everything is layered together. So in our third and final layer here for the highlights, of course we will go to the expression and we will just increase this even further, and we will bump up the gain value here in our grade node, and also maybe we can just introduce a little bit more yellow here. And this is pretty much the result that we get. If we preview this, we can see we have this very nice stylized look, and we can either keep this as it is or we can start to smooth some of these layers. So before our expression we can add a blur and we can blur out some of these highlight layers. Maybe we can reduce the threshold here. Maybe we can play around more with our blur. Let's maybe add another blur over here on our second one, blur this out a little bit. And of course we can still, let's get rid of this dot, we can still blur our main layer. So our first one, we can do something like this. So now it's a little bit more, it's a little bit smoother overall, I would say. So we have all of the options that we had in our previous example. And as one final thing, we can also add a very simple outline as well. Now for our outline, we will need to reference the results that we get from our blur and pretty much use this alpha from our expression. So this alpha over here. So let's do another postage stamp down below and link this up to our expression all the way here. And again, we will hide the connection with Alt H. And from this alpha, from over here now, we can do a shuffle. We will shuffle the alpha into all of our channels, RGB, and we will do an erode, push our pixels out, and then merge this back on top of our original result, and we'll set the operation to minus. And now from here, in this case, so normally we do an invert to get our black and white values, but in this case we can just add this as it is, but maybe we can just grade this so it's a little bit more orange. So I'll just reduce the green and blue channels, maybe increase the red, and we can just simply merge this on top. So we can either keep this as it is, or we can sometimes use a plus operation. It won't make much difference in this case, but this is the options that we have now. If we are dealing with bright and emissive effects, we don't really need to have our outlines be black. So this is with the outline, and finally just one last layer that we can add here is going to be a bit of glow as well. So if we do a crop at the end, we can add an AP glow, and let's disable effect only and maybe make something a little bit more subtle, but we end up with something like this. So if I preview a few frames, we get this result, and probably we can blur our layers a little bit more. So this will be completely up to you, depending on what result or what look you are going for. And there's still going to be a lot of things that we can do here before we cut our alpha and even after we cut our alpha. And throughout this workshop, we'll experiment a lot and push these techniques a lot further. But at the core layer, this is pretty much how we will set up the effects. We will break them up into layers with highlights and either remove some of the details from the render or add our own details, both on the cel shading side and also on the outline side. And we will be able to express a lot of creativity and flexibility through these techniques. Now, we can still probably make this a little bit more interesting. We can maybe introduce some gradients here. So maybe for our first layer, we can replace this with a ramp. And if I press Q to bring back my gizmos, let's go ahead and create this top to bottom gradient. And let's also recolor this towards a red over here. So we can introduce maybe a little bit more depth to our colors. And this goes back to my point about ramps and gradients. This will be present in a lot of more modern anime, I would say. So it's also something that you can experiment with. And again, we can introduce our distortions for the edges here. So on our outlines, I will just use the X distort gizmo for this, but we can see now that if I decrease the distortion amount here, let's do something like this, decrease the blur map and maybe the size of our noise, we can also introduce even more animation on the outlines. So this will layer really nicely with the animation that we already have. And of course here for the Z value, we can connect this up with our frame expression. So maybe frame divided by 5. And if I press play, we end up with something like this. So this is the result that we can get when we render the effects as volumes. And we can see that for the most part, when I play the animation, we get a pretty smooth result. So there's not a lot of really obvious or unnatural jittering going on. We have a pretty smooth flow and motion, as opposed to what we will have, and we will see this later when we render as a mesh. We are going to see a little bit of a difference between the motion, so the animation between these two types of renders. So this is going to be one of the key differences when you render either as mesh or as volume. And these differences will start to make a little bit more sense as we progress through the other examples as well. So with the next lesson, let's take a look into how to set up a render using points or particles and see what differences will be there between the volumes and the particles. So I will see you in the next lesson. So for the second option of rendering, let's try to see what results we will get if we render this as points. So back in Houdini, we'll step inside our geo container. We have our volume here. Let's use the same sphere to generate some points and push them along with our volumes. And let's start by just doing a scatter here. We will add an expression here for the global seed $FF, turn off relax iterations, and just increase the force total count here and disable max point limit. So let's also introduce some noise here. We can do this with an attribute VOP, and let's just do a turbulent noise. We'll set this to a simplex. We'll do a fit range and plug this inside our color. Alright, so we get something like this. Let's decrease the source min and maybe the source max. And let's play around with the frequency here. Probably just decrease this slightly. Let's do something like this. And maybe increase the source min here so we have some contrast. And we can also animate this. If we right click and promote all of our input parameters of the noise, we can go up and maybe we can just animate the Z value here, our third component. We can set this to a $T the expression. And now we also have some animation. Probably we can increase this. Let's multiply this value by 5. All right, so probably this is too much. Let's try a value of 2 instead. Something like this will be fine. It's not super important in this case to add this noise, because again we'll mostly work with the alpha channel, so our points don't really need any color for now, but it's going to be easier for us to preview what results we are getting if we have a little bit of color variation. So this one, this will be our source. I will plug this inside a pop network, and inside here let's set the emission type to all points, disable the guide, and for our birth let's try a value of 2 to start with, and we will want to pick up the velocities of our volume simulation. For this we will use a pop advect by volumes, but in our main projects we will do something a little bit different, something that will allow us a little bit more control. But for now we want something quick and easy, so let's go back up and we want to reference our null here. Let's copy this and let's go back inside here and paste this in our SOP path here. By default this will look for our velocities, and we want to use, let's do update position. So if we press play, we should see now that our points will move along with our smoke. Maybe this is a little bit too much. Let's try to remove a digit here, so essentially 10 times, have 10 times as less points. So let's do something like this. This is starting to look pretty decent, I would say. Maybe we can make our particles last a little bit less as well. Let's go back inside here and reduce the life expectancy, and also maybe introduce some life variation. Let's try something like this. All right, let's press play, and we will end up with something like this. I think this should be fine for what we're trying to accomplish here. Again, it's going to be a very simple example. So if I go up, I can do a null from here, and let's do out PRT, and let's also try to bring these in Solaris. So I will copy the path to this node here. I will Control C. Let's go over back to LOPS, and let's do a separate chain over to the side. We can start with a SOP import. We'll paste the path here. Again, we will want to bring in our scene, our camera. So we'll do a scene import set to cameras, and let's also do a karma render settings. And here we'll point to our camera, and let's leave the resolution as it is. Set this to XPU, and if we do a test render, let's see what we get. So by default we don't really see anything. Our p scale, so our particle size, is too small. Let's go back to our object level. We can change this directly in Solaris, but it's going to be a bit easier to set up in SOP. So we'll just go to the object level here. Let's do this with a simple attribute wrangle, and we'll say that at p scale equals, let's start with a value of 1. So we'll just set this to 1 for now, and if we go back to Solaris, we can do another test render. We can see this here. Let's maybe just spin the viewport over here, jump back over to object level, and inside here we can lower this now. So let's try a value of 0.1. So now this is starting to get a little bit closer to what we are after. Let's maybe try 0.05 or maybe 0.03, and something like this I believe is looking good. Maybe finally I will settle for 0.05. It's always going to be a balance between having a low enough p scale but also having enough points to create a smooth result. So in this case, if I were to unpin the viewport, we are running on 100,000 points, and probably we would need something closer to 1 million. I will maybe increase this slightly, so from around 3,000, let's maybe try 1,500. And let's reset our simulation so we can get to this state as well. So now we have 500,000 points. This should be more than enough in this case, and I might want to lower our p scale to 0.03. So if we head over back to the LOP stage, we have something like this. Now again here the alpha channel will matter, so if we go, we have the correction toolbar opened, and if we press on the alpha, this is essentially what we will work with when it comes to Nuke. Now a couple of things that we can do here: we can smooth this out overall directly in rendering by first incorporating motion blur and then also running a denoiser on this as well. So these two factors, the motion blur and denoiser, will be extremely important moving forward. We've seen in the example where I've shown you the traditional way of cel shading, we've seen the difference that the denoiser can make when creating the transitions between the layers to get that smooth transition, and also the blurring that we usually do before cutting the alpha for all of these layers. This blurring, we can see that it does help a lot. So generally, the smoother result that you can get directly in render, the better off you will be, especially when it comes to this stylized kind of rendering. So with that being said, we will need first of all velocity on our points. We can go back to the object level, and before we export this to Solaris, we can do a trail node, and let's set this to compute velocity and match by attributes. So if we check our velocities, we have them on our points. If we go back to the stage level here in our camera effects, let's turn off depth of field, and in our motion blur we want to use velocity blur. So hopefully now this will work on our points. We can see this here, and we will also turn on in the filters tab, we want to turn on NVIDIA Optics Denoiser. In this case it doesn't really make much of a difference because we do have for the most part a pretty smooth result. Now we might want to actually scale down the p-scale towards this part when our points age to a certain point. So we might want to map our p-scale to our age. So let's maybe go back and let's do, instead of this attribute wrangle, let's run an attribute VOP. Let's rename this one to set p-scale, and we'll step inside and we'll grab our nage attribute with a bind. We'll set this to nage and we'll just do a bind export and export this to our p-scale. Let's also do a ramp parameter here and set this to a spline ramp. So now if I go up, let's reset our ramp, and we will probably need the reverse of this. So we'll do something like this, and we might want to make this into an exponential ramp, and I will set the interpolation here to B-spline. So we want to scale our points along our edge to something like this, and we'll also want a global multiplier on them. So let's also do a multiply here and promote our second input. So this one we can rename to global p-scale multiplier or something like this. And if we go up, we can set this to the back to the value that it had earlier, somewhere around 0.03. Let's go back to rendering, and now if we check our render, we should see that they are tapered a little bit towards the edges here. So I'm pretty happy with this result. This is just a very quick and standard way in which we can set up this particle rendering. And if we export this as it is and use this in our compositing and apply all of these same effects that we did over here for our volume, we would get the same result. And in fact, let's go ahead and bring our point render that I've prepared. So let's go ahead and I'll press R. Let's bring our fire PRT render, which looks something like this. So pretty close to what we had earlier. And if I press A, this is the alpha channel that we will work with. Again, we are using a different frame range here, but the thing is that we can pretty much just copy paste the same setup that we had earlier. So let's go ahead and just grab all of these nodes. Let's copy them and paste them down below and just link this up to our render, to our new render. All right, so we have something like this, and as a final result, we have this, but here we will just need to set some new values for our threshold. So if we go to the first layer in our expression, we will just increase this by quite a bit. So we get something like this for our base layer. Let's do something like this. And for our second layer here, if we increase our threshold, we can see that at a certain point, because our alpha is not really that high as in the ranges that the pixels have, so it suddenly goes from this value here, it will just go all the way to 0, which is not really ideal if we want to isolate a smaller part of our fire in this case, or for this highlight specifically. But what we can do is we can just directly affect our alpha that we are using over here. So if I press A, we can do a radial. In this case, we can just drop down a radial, and so our radial looks something like this. Maybe I will just decrease this a little bit, and we can do a merge between these two alphas, and I will set the operation here. In this case, we can use something like a color burn, and we can see the result that we get. So we can create this nice cutoff on our alpha, and now when we merge this on top and I press A to go back to RGB, we have filtered a smaller region of our fire. So we can control this with custom masks, with radials, and with other effects to get our alpha exactly in the position that we want. We can do the same thing for our second layer if we wanted to. I think in this case it's going to work out fine. And if we look at the final result, we end up with something like this. So first of all, when we preview these layers, maybe we can increase the blurring here for some of these layers. Let's do something like this, and let's take care. Let's look throughout all of these other layers to maybe increase the blur here. So we get a very similar result for the most part as our volumes, and we can notice that we do have the same kind of smooth natural movement in our animation. So this result will be very similar to what we get from volumes. Let's preview this with the AP Glow. So if we look between these two, they look pretty close in terms of design, and they will also feel pretty close in terms of movement as well. So smooth and not super jittery, so pretty close. But the main difference between these two methods is going to come down to what we can do with these layers directly inside Houdini. So we can notice that these two are a little bit different in shape, and this is because we can apply post-simulation deformations on our points. So if we go back inside Houdini, we can go back to our simulation over here, and once we have the simulation, we can do a lot of different operations to get our points in a very specific shape. And just as an example, what we can do is let's just run a linear taper on our points. I'll press enter, or maybe I can just set the capture direction to 0, 1, and 0. I'll increase the capture length by quite a bit over here so that it covers our whole area, and maybe I will reduce the capture origin and just try to get this roughly into place. And what we can do is, if we enable the ramp, I can add another dot over here, and I can just squeeze the particles towards the edges here, towards the end, and maybe I'll add another point and I'll set this to a B-spline. So this is just as an example one of the things that we can do here. So again, the main difference between the volumes and the points will be the things that we can do at the Houdini level, so before we actually render them. In general, working with points will be a lot easier to create any kind of deformations. We can twist and pull specific areas of our points and reshape our simulations, and this reshaping and controlling this shape will be extremely important when it comes to this kind of stylized effects, because we are not really looking for highly realistic simulations as far as the silhouettes and the shape reads go. So throughout our projects, we are mostly going to render the simulations as points specifically for this reason. Now, we can render them as points. We can also from this point turn them back into a volume if we want to. So this is fairly common in magical effects as well. But again, with this linear taper, this is just a very simple example on some of the stuff that we can do. And this will be the main difference between these two styles of rendering. It will come down to the things that we can do before we actually render them. So this is how our techniques will work with the points render. And with the next lesson, let's take a look into our final option, which will be rendering the effects as a mesh. So I will see you in the next lesson. So let's take a look into our final example, which will be rendering the effects as a mesh. Now, to create this mesh, we can base this on our point setup that we already have. And from here, we can turn this into an SDF VDB. So we can do a VDB from particles, and we can append this here. By default, I always like to change this minimum radius here. I'll set this to 0. We can already see something happening, but the thing is that we already have a p-scale set up here. Now I will want to override this for now, so I will just bypass this node with Q, and now we can see we have we essentially just default the p-scale to a value of 1, and this will act as a multiplier. So we will treat this meshing as we would normally do for any type of liquid simulation, and there's quite a few things that we can do here to smooth this out, to retain the curvature. And there's also post-processing stuff that we can do after we turn this into a mesh. So really there's an entire art to just meshing a particle simulation into a liquid mesh. We could do an entire course just about this single aspect of meshing particles. But for now we will keep things simple. So we'll turn this into an SDF first of all. And from here we can just do a VDB. Let's do convert VDB. And we'll convert this into polygons. So if I press Shift W, we can kind of get an idea on our geometry so far. Now, probably since this is a stylized look that we are going for, we don't really need as much detail as we would normally in a high resolution liquid simulation. We can go to our VDB from particles, and I might just bump up the voxel size to 0.2, and probably we can also increase our radius scale a bit. So now we get something a little bit smoother overall. And to increase the smoothness, we can do a VDB smooth SDF before we do our conversion. So here we will do a VDB smooth SDF, and we can already see a much smoother result, so a better result. Here I will probably go usually with mean curvature flow, and I will do this for meshing normal liquids as well, and probably in this case I might want to reduce the iterations a bit, so we end up with something like this. Now again, for stylized effects, we might even want less resolution on our meshing here, so I might bump this up to 0.25. And now also I'm not gonna spend too much time on this very simple basic simulation, because this will be just to illustrate the differences with mesh rendering. So after this convert VDB, finally what I would like to do, and I do this usually also for normal liquid simulations, I drop down a peak node, and here we can just squeeze our values a little bit. I can set this to maybe negative 0.1, and we can see that this tends to sharpen up our edges a little bit, and it works especially well with stylized effects. So from here we would do a null, and we can export this to Solaris as well. We can do out mesh, and let's copy this. Let's go over back to LOPS, and here we can probably just copy our initial setup that we had for our volume. Let's go ahead and duplicate all of these nodes, and I will just replace my SOPF over here for the SOP import. So we have our camera, a Karma physical sky. Now probably we don't need this one, and we have our Karma render settings, and let's take a look. If we were to render this as it is, this is what we have. So right away we will have some differences in the overall shape that we are going to get, but the biggest advantage in rendering the effects as a mesh is that we can carry out with the render certain passes, and especially we can carry out certain point attributes. So we can also export the UVs, we can export costume passes, we can export the normal pass, and we can also export the facing ratio. So similarly to how we've done this with our helmet, we can bring up our, let's go to our image output here, and we can select from utility, we can select our facing ratio. So it's going to be this pass over here. So this will be very, very important when it comes to any mesh that we export moving forward. We can of course grab our normals and other AOVs as well, and in fact we can grab our ambient occlusion as well, and we can see this over here. So this can be a useful pass. Of course here we can run a denoiser on all of our AOVs. So in filters we can choose NVIDIA optics denoisers. and we can select all of the AOVs here. We have to be careful when we are running the denoiser on all of our utility passes as well, because if we were to export, let's see, if we were to bring up our camera space, so our Z depth or our texture coordinates or even the world space, so our regular P, these values have to be left intact in order for the passes to work properly. So we have to be careful where we run our denoiser, but usually we can run it over the facing ratio and especially the ambient occlusion. We can run it here and we can see that for the most part it does a really cool job. If I were to not use any denoiser and with denoising, this gives a very good result. Now, aside from the utility passes that Houdini, or rather the Karma Render settings node provides by default, we can just bring out our own attributes. So in this case, just to give you an example, if I go over back to the object level, here what we can do after our peak, if we do a measure, labs measure curvature, we can select this here and we can use either the convexity or concavity. In this case, we'll want to use the convexity. Let's turn off visualize output actually, and let's just create a visualizer for this ourselves. We want to preview the convexity, so I'll turn this on, and if I turn this on, we can see this over here. We can go to our adjustments here, we can increase the multiplier, maybe blur this out a little bit as well and play around with our ramp. So we just get this nice gradient map over the essentially the curvature of our edges, which can be a useful thing to have. So all we would need to do is go over to lobs, and in the extra render vars I can hit plus. I can give this a new name, so we can do something like curvature, and for the format we can export this as a float, and the data type will be float as well, so I'll choose float here, and the source name will be, let's actually, it's I believe the attribute name is called convexity, and the source type has to be set to primvar. So hopefully if I do a render now and inspect our AOVs, if we go to curvature, we have this black and white mask, so we can now use this in our render. So this is again just to give you an example of some of the stuff, or rather the advantage we have when it comes to exporting this as a mesh. So if we head over back to Nuke, let's go ahead and bring up the mesh render that I prepared. So it's going to be this fire mesh. We'll bring this out over here. And let's first of all do our time shift, but in fact let's start with the same setup that we had earlier. I'll grab all of these nodes and copy them down below. So if we just run the setup as it is, this probably won't work as nicely because we essentially don't have a gradient on our alpha channel. If I were to press A and go over to the information tab over here, if we look at the pixel values, we can see that the alpha channel has a value of 1 throughout this entire mesh. Meaning that when we do our expressions here, we're not really going to get anything except the full value of our mesh. So we can see with our first layer and our second layer, now we have this radial here which is helping us, but let's go ahead and get rid of this and we will see that these are roughly the same. So our first layer and our second layer, and this is because of course if we go to the expression and press A, we can see that nothing really changes, probably only because of the blur. Something changes here, but if I were to disable the blur and look at my threshold values, we can see that this isn't really doing much at all. So in this case, what we can do, and in the same way that we did for our helmet, we can run our setup over another AOV instead of the alpha. So from our time shift here, let's do a shuffle and let's bring in our facing ratio and plug this as our alpha. So if I press A, we now have a very cool gradient. We have all of these nice values between 0 and 1. So if we run this over our first layer, let's maybe go ahead and drop down the blur a little bit. So now this will be our first layer. If I press A, go back to RGB view, we get something like this. And for our second layer, if we go to our alpha now, we can see that indeed we do have a different version of our first layer. So if we go to our result here to RGB view, we get something like this. And we can still play around with our blur if we want. more or less detail. And for our second layer as well, if we look at the result here, let's go to our expression, and maybe we need to turn this down a little bit, so our threshold value. So now if we preview this result, we have something like this. Probably we can increase this even more, and we can now play around with our settings here, and we can see the different results that we get. So finally we run our edges and our AP glow, and this is the final result that we have now. So if we press play, one thing that you will also notice is that this might be a little bit more jittery. So this will be one of the, I would say, disadvantages. Now it might not be really a disadvantage because it might be a look you're going for, but generally with an actual mesh you might get a little bit more of a jittery motion. We will have kind of like areas, if you look at this part and go frame by frame, we can kind of see we get maybe not the smoothest result in terms of motion, as opposed to our version where we either render this as points or as volumes. Usually these ones will be a little bit more stable, but we will have other advantages when it comes to meshing. So it's going to depend exactly what look you're going for. One thing that you can do is if you render something as points or volume, we can also mesh this simulation and we can export it as a mesh render and just use the utility passes and combine some of the layers that we have from this render, just combine them over here. So this is something that we will do in our final project. So really it's going to be a combination between all of these different methods of rendering that's going to add up to our final effects in the end. But now for our meshing, we just reuse basically the same setup that we had earlier, but we still have our custom AOVs. So here I will actually make some more room, and let's do another postage stamp and point back to our, in this case we want to reference our time offset layer instead. So let's hold down shift and create this connection. Now we can do a shuffle and let's bring out our convexity. So if we plug this, we can just populate all of our channels in this case by holding Alt, and if I do a gray node, maybe we can just turn down the gamma a little bit, decrease the white point so we have a little bit more of a sharper look. We can also maybe run an Enroll node here and we can maybe squeeze our values a little bit, and with another gray node let's go ahead and introduce a little bit of orange here as well. So now I can just simply merge this on top and we will have this nice extra detail. Probably I will want to increase the brightness here, but we can see the result that we have, and maybe I will also decrease the dilate here even more to squeeze these values, have a more stylized look. But again, this will be just to give you an example of some of the stuff that we can do now. So if I increase the contrast enough here and maybe also introduce more red, we have this kind of nice additional layer of detail which we can add on top of our render. Now here we can also see a little bit clearer our jittering that happens, especially with this extra layer. We can see that it's not really the most stable result, and there are certain things that we can do directly in Houdini to try to smooth out our mesh and maybe add a little bit of smoothness directly on our attribute. So all of these techniques, when it comes to using the effects as a mesh, will need a little bit more finessing, will need a little bit more work in general to make them feel right when it comes to motion. But hopefully this gave you an idea on the power of rendering the effects as a mesh. Now in our actual projects we can export the UVs, and we'll do a lot of stuff with the UVs to introduce our own noises and our own layers created directly in Nuke, and some of them exported from Houdini. So there's really a lot of stuff that we can do, and case in point, on the final dragon shot that we are going to work on, I initially rendered the dragon in the first half as a mesh, and we can see this over here, and so this is one of the first versions that I got to. We can kind of see, even though I think it's a good result, we can kind of see a little bit of jittery in our mesh overall, especially since it's such a large object. We have maybe too much of a chaotic look at places. Now I wouldn't call this necessarily wrong, because it is a specific look that you can go for. Maybe if you do want a more chaotic feeling effect, this would be the way to go. But in my case, I just wanted something a little bit smoother, so this is why I opted to go with particles instead. So the final version will look something like this now, and we can see this especially in these areas here in the center of our dragon. I think the motion feels just a lot smoother in this case if we compare it to some of the earlier tests. So again, it will come down to preference, but these are the options that we have essentially. So hopefully this will give you a better idea on the workflows and approaches we will have during this course, and the advantages and disadvantages between these different styles of renders. And with the next lesson, let's take a look into the importance of achieving depth in your renders and some of the options we have when it comes to achieving this depth. So I will see you in the next lesson. Now, when it comes to creating depth in a 3D scene, we essentially have three ways of achieving this. So the first way will be through manipulating the values, and the second way will be through manipulating details, and the third way will be through manipulating saturation. So value, detail, and saturation, and I would say the importance of these methods will be in this order, meaning that value will probably be the most important one when trying to achieve depth. So I have just a very simple render here from Houdini. It's just really a bunch of cubes together with a camera, with a simple light. And we will use this as an example and see how we can add depth to this scene and also turn it into a stylized render with outlines and other detail like this. So from this render, I have prepared a few passes over here. We'll go over these one by one. So the first one will be if we do a shuffle. Let's do our value in one expression here between brackets, and let's shuffle out our albedo. So our albedo will just be the color of our material without any shading. So essentially, if you think about a drawing, this would be basically level 0, and if you don't have any material differences between the objects, so in this case, since all of the objects have the same material, if we would just do a simple flat shaded style like this, we wouldn't be able to tell exactly what's going on in this scene. So let's take a look first of all with values and see how we can implement this in our in the creation of the depth. So this will be our base layer, and let's go ahead and add another dot over here, and let's bring in another shuffle, and of course we will use our camera depth. So this will be this depth extra layer. Let's go ahead and plug this inside the alpha, and if I press A, we have values above 1. We can drop down a gray node, set this to alpha, and we can increase the white point so that it matches the actual depth in our 3D scene. So all of these objects are pretty large, so we will have to push the white values. We will push this, let's just increase this until we get mostly all of these cubes here and maybe some in the back as well, and we can play around with the gamma as well to maybe decrease some of this contrast. So the first thing that we can do is if we go back to our albedo over here in RGB view, we can drop down a grade, and let's point the mask to our camera depth over here on this other gray node, and let's go ahead and just decrease our gain, and I would like to invert this. And usually with depth expressed through values, you will often find that the further away the objects get from the camera, the brighter they will be, so the higher value they will have. And you can more or less see this in mostly any kind of landscape image. The further away an object is, the more it will become more transparent and just a little bit brighter. We can go the other way as well, and this will be a case-by-case basis, but in this case we will just do the inverse of this, which will be brightening up the objects in the back. So we can adjust this gain value here. We can go back to our grade for the alpha. Maybe we can increase or decrease the gamma and play around with the values here. But something like this, we can already see we get a much clearer feel on the depth of this render. Now, because we don't actually have anything behind our background here for our objects, we can see that we have this alpha with nothing in the background. Let's go ahead and just try to fill this up with a white space. So I can grab the same mask that we created over here. I will do another grade node, again set to alpha, and I will point this to my render. So now this mask is pointing to the alpha of our main render, meaning that if I now lift up the values, I can lift this all the way up to 1, but I can hit invert, but now this will only affect the background of our image. So we have this white space over here, as we can see, and we can do a shuffle, and let's plug the alpha into RGBA, and we can just do a simple merge on top of our original render, and we can set this operation. In this case, let's maybe set it to screen, and if I press A, this is now the result that we get. We can probably also do another grade node here and squeeze the gamma just so we have, or rather focus on this area more in the back, so we can kind of see the results now. We can see also that because we are overlaying this background, it's kind of brightening up some of these buildings here in the back, because the screen is kind of an additive operation. So what we can do from here, we can also we can see that these values go above 1, so we can just do a clamp, and this will sort of help us to get rid of this problem we were having, and now the render is a lot better integrated with the background. We can now of course still go to our controls over here, and maybe we can play around more with our other settings. Let's maybe take a look. Maybe I can push this further back just so we get a little bit more of our of the buildings in the back. We can do maybe something like this. So again, this is a black and white image, but we can already have a much better sense of depth, and this is achieved through values. Maybe overall I would like to increase this, and let's go ahead and also increase the gamma of our mask here, just so we have a smoother transition. So this would be the first step, achieving it through values, and this is, like I said, probably the most important thing to have. And achieving this depth through values is something that you can apply really to any type of render, whether it's stylized or realistic, or even if you're just doing a drawing, or you are working on an image. It's not exclusive to an animation. This is something that you can implement throughout all your renders, and it's always something that you need to be mindful of. If you have a colored image, so for example, if I were to color this, let's say maybe, and we will color this in a second to blue either way, but if you had an image with color, a lot of times it's worth just doing a saturation and setting it to 0, just so you can check your values and see if indeed this depth is working. Because if your values work, then no matter what colors you will use, it will probably look fine. So for example, if I were to change this to a red value here, if I were to disable the saturation, we can see that we can still clearly see the depth in our scene. So this is why the value aspect of achieving depth is very, very important. So this is with values, and in the case for stylized rendering more specifically, it's going to be important to achieve this through details as well. So let's go ahead and try to add some outlines to this render. Let's go ahead and we'll use another shuffle, and let's probably just do a postage stamp just to keep things organized, and point this over here back to our render. Press Alt-H to hide the wiring, and in the shuffle now let's base our outlines on the normals. So I'll grab the normals, link them up to our RGB channels, and we can do a find or an edge detect. So if we do an edge detect as we did previously, if we press A, we have a decent result, but we don't really have enough control. I would say there are some things we are missing. We can't really control properly the size of our edges. So another thing that I like to do in this case is if we just do a manual type of edge detect, meaning that I can just do a blur, and I will blur this just 1 or 2 pixels, and I will just subtract this now from our own image, so from our cells without the blur. So with this merge now I can do a minus here, and we can kind of see our edges, and to get rid of this color all we need is a saturation node, and we can set this to 0. So also we can do, let's maybe do an invert from here, and if we do a gray node I can drop down the gamma, and we can hopefully start to see our edges a little bit better. Maybe we can increase our black point here, and we will do a white clamp so we don't get values over 1 and we just have this black and white edges. And now with this blur over here, we can control a lot better the size of our edges. So we can do something like this. We can either do a blur here or we can do an erode in a similar way to how we do the outlines of an exterior object. Only in this case, we just really have the interior, so to say, of our render, but we can also play around with erosion here. And if I increase this, we can see the results that we get, and we can couple this, either get rid of the blur or just couple this with a blur, and really this way we have a lot more control over the edges. Now, one thing that's happening here, we can see that some edges are missing. For example, on this cube over here, really there should be an edge. If we go to our shuffle, we can see that because this is a very hard surface, as it is over here, we don't really have any differences in color between this region over here and this region over here. So the edges are happening only where there is difference in our pixel values. This is why we get an edge over here, for example. So on this part right here, and we can see this in our render, we have this over here, but we don't have anything over here. So in this case, what we can do is we can introduce this difference between the pixels ourselves, again by using the depth pass. So what we can do is we can run a grade node and we can point this back to our shuffle over here. So this grade for our depth, let's maybe make some room, and I will point the mask to this grade node over here. And if we just look at the result, if I increase the gain now, we can kind of start to see a subtle difference between our edges. So now if I look at this area over here, we have 1.55, and this area over here will be 2.2. So we have a subtle difference here, and we can kind of see this as I get closer. I think probably it's worth doing just a separate grade node for this, and let's point this grade node back to our depth instead. So we are just essentially recreating our depth mask. So if we go to our alpha here, let's increase the white point. Let's do something like 200 and press A. So we have this, but now we can control this specifically for our normals, meaning that if I were to increase or decrease the gamma here and play around with some of these other settings like the white point, we will see a bigger difference. Let's maybe go ahead and we can also maybe squeeze the gamma a little bit. Again, we are just interested in creating a difference between all of these colors, and hopefully now we can kind of see a difference between this green and this green. So if we go to our result here, we can see we finally get an edge here as well. So this is with and without our grading adjustment. Now probably we should play around a little bit with our mask here as well to get rid of maybe some of these really dark parts, and maybe I can also play around with the gamma here or the gain. Let's try to increase the black point as well and see if this will give us a good result. Or let's try to let's set the gamma here, let's increase this instead, and maybe I will push the white point a little bit. So I think this is giving us a pretty decent result. Alright, but essentially from here we will just do a merge and merge this over our current image. I'll set this to multiply, and this is the result that we have. So already with the outlines we are getting a closer look to a stylized shader. But now what we can do is we can decrease the detail of this layer as it travels across our scene. So as we get further and further away from the camera, we can start to lose these outlines. Now, first of all, I would like to run an erode and just make them a little bit bigger. So I will decrease the size. Let's do something like this. And now with a mask, we can try to fade them off in the distance. So we can also do another dilate for this. Let's do another erode here, and let's grab another one of these grading adjustments, and we'll point this back to our depth layer. Alright, so I'm just making a duplicate of this grade. If we go here and press A, this is the current mask, and we can use this in a secondary dilate node here. Let's go to the result, and here we will want to increase the size. So we can see when I increase the size, because it's using this mask over here, we start to lose these edges, the intensity of the edges, the further away they get from our camera. So this is exactly what we want. When we preview this on top of our render, we can see that with this dilate, we get this loss of detail across our depth, and maybe we can further increase this intensity threshold as I play around with the mask values in our alpha. And now I would probably want to get rid of this dark edge over here. This is happening because again we don't have this alpha present here. Maybe if we point this back to the alpha of our render as we did earlier, or actually we will have to do this as a secondary adjustment. Let's set this to alpha and let's link this up over here to the alpha of our render. And if I increase the lift value and take a look, maybe set this to invert, maybe we get rid of this edge. So if we go to our dilate with the secondary gray node, we can see that we kind of get rid of this edge. There's still a little bit of adjustments that we will need to do to make this perfect, but again this will be just an example of some of the stuff that we can do here. And here again we can just run a simple distortion. We can use the X distort. For this, let's maybe decrease the blur size and decrease the blur map and the blur size here as well. Maybe make this a little bit rougher. And so we have something like this. Maybe we can increase, and maybe we can increase our original dilate values here. Let's do something like this. And we can also run a depth mask on this distortion as well. So maybe for now I will just point this to our grade over here. So not the distance map, but the mask. Let's try to grab this mask, point this over here, and in our settings we will hit invert as well. So now we can see that as we get further away from the camera, our edges will get less distorted. So it goes back to that loss in detail across the distance from the camera. So this is an example of the stuff that we can do through losing the detail. And finally, we can also take a look at saturation. This can be important as well. So for example, if I were to just give this a simple color like a blue or something like this, if we run a saturation and point this to one of our masks here for the depth, we can set this all the way to 0 and we can already see this difference in depth here. Probably we can remap these ranges a little bit. Let's couple another gray node here and let's run a gamma adjustment on this, and maybe this makes a little bit more sense. So just a very simple example on the note of saturation. We can see with and without our saturation adjustments how much this can help. So these are the three key things to keep in mind: value, detail, and saturation. And case in point, if we look at our projects, if we look at the Dragon Attack project, we can see this depth is expressed. If we look closely, we can see if we look at the detail over here on our dragon and look at it over here, we can see first of all a difference in value. So this will be much brighter than this part over here, and we can also see a clear loss in detail. So this is very intentional. If we had the same amount of detail as we have over here throughout this entire dragon, we wouldn't be able to guide the eyes of the viewer correctly, and essentially everything would be competing with each other. So this is why it's also important to have this depth incorporated in your renders so that the viewer can have a better sense and spatial awareness, but also guide the eyes towards areas of interest that we want to. And hopefully we can clearly see the loss of detail as we go further along the dragon. So this was very intentional. I wanted to bring all of the attention, or most of the attention, towards this part over here with the sword and the hand and the head and the character. And we can also take a look at the other example we have over here. So in our running shot, we can clearly see this is mostly expressed through value. So we can see in this case the shadows closer to the camera are going to be much darker than the shadows towards the edges over here. And in the case for some of these frames, this also creates a nice contrast with our character. So because we have this bright spot in the background over here, this will make our character stand out a little bit more. We can also see a little bit of loss in detail as we get further away from the camera. Now there isn't any saturation adjustments in this case since it's meant to be a black and white render. render, but we can see the depth expressed mostly through values and loss of detail. So these are some of the examples that we have. Now we will incorporate this depth throughout all of our projects within this course. So this is why I wanted to go a little bit more in detail about how we will achieve this. And again, it's a very important concept, whether you're doing stylized render or any kind of image really. You always want to have contrast either through value, saturation, detail in your image, either to express depth or in some cases bring more attention to certain elements in your render. And these are some of the ways through which you can achieve this. So hopefully now we understand the core concepts that we're going to implement throughout all of the projects. And with the next lesson, we can start with our working projects and start with the demon fire shot. So I will see you in the next lesson.